Okay, let's dive into this story. It's about a philosopher, a ship way out at sea, and a theorem that completely changed how we see the world. You could even call it a geometric heist, one that stole our fate back from the gods.
So we're going to start with this line from Dante's Paradiso. Now, it sounds a little cryptic at first, right? But what he's doing here is actually giving a nod to this deep, elegant geometric truth. He's asking a rhetorical question. Is it even possible to draw a triangle inside a semicircle that doesn't have a right angle? And as we're about to see, the answer to that is a big resounding no.
And this brings us to our main character, Thales of Miletus. Living way back in the 6th century BC, Thales wasn't just some philosopher sitting around thinking deep thoughts. He was more like a mathematical troubleshooter, using logic to solve real, practical problems in the ancient world.
What's so cool about this time period is that it was this huge turning point for human thought. See, people were starting to shift away from mythos, explaining everything as the whims of unpredictable gods, and moving toward logos, which is all about logic and reason. Thales was right at the forefront of this, looking for the hidden patterns and reliable rules that actually run the universe.
Which leads us to the central mystery of our story. Thales was famous for supposedly solving this huge problem, how to figure out the exact distance to a ship from the shore. I mean, think about it for a second. No lasers, no radar. How would you even begin to do that? It seems impossible, but we're going to solve it, right here, together.
The secret weapon Thales had up his sleeve wasn't a physical tool at all. It was an idea. A simple, elegant, and just unbelievably powerful geometric theorem that now, of course, is named right after him.
And the theorem is beautiful in its simplicity. All it says is this: take any circle, draw a line straight through the center. That's your diameter. Now, pick any other point on the edge of that circle. If you connect those 3 points to make a triangle, the angle at that third point you picked will always be a perfect 90-degree right angle, every single time.
Now, what's so amazing about this isn't just that it's true, but that we can prove it so cleanly. So let's build this out together. Here's our circle. We've got its center point, we'll call it O, and a diameter AC. And then we just place our third point, B, anywhere along the top edge.
Okay, this next step is the one that unlocks the entire puzzle. We're going to draw a line from the center, O, straight out to our point B. Now, what is that line? It's a radius, right? And so are the lines OA and OC. That means all 3 of those lines are the exact same length.
And just look at what happens. That single line we drew splits our big triangle into 2 smaller ones. And since each of these smaller triangles has 2 sides at a radii, meaning 2 sides of equal length, they have to be isosceles triangles. Now, the key thing about isosceles triangles is that their base angles are always equal. So let's go ahead and label the equal angles in the left triangle alpha and the ones in the right triangle beta. Now we just need one more piece of universal truth from geometry, something you probably remember from school. The 3 angles inside any triangle always add up to 180 degrees. So if we look at our big triangle ABC, what are its 3 angles? Well, we have alpha, we have beta, and that top angle is alpha plus beta.
And from here, it's just simple algebra. You've got alpha plus beta equals 180. That simplifies down to 2 alpha plus 2 beta equals 180. Divide the whole thing by 2, and there you have it. Alpha plus beta equals 90 degrees. That angle at point B is, and must always be, a right angle. And that's the proof. Pretty neat, huh? Okay, so we've proven it. But the real magic here isn't that it's just some abstract idea for mathematicians. The magic is that this theorem is a powerful, practical tool you can use to actually interact with the physical world.
Here's a perfect example of that power. Let's say you want to find the exact center of any circle. All you have to do is use the theorem in reverse. Grab anything with a right angle. Seriously, even a folded piece of paper works. Place the corner on the edge of the circle and just mark where the sides cross. The line between those 2 marks, that's a diameter. Do it one more time from another spot, and where those 2 diameters cross, that is the exact center. Simple, practical, perfect.
So now let's circle all the way back to our original problem. How in the world does a theorem about circles and right angles help Thales figure out the distance to a ship miles out at sea?
Well, the thing is, the direct solution probably didn't involve drawing a giant semicircle in the sand. Instead, it's much more likely Thales used a closely related idea, one that's also often attributed to him, which we now call the intercept theorem, and it's all about the power of similar triangles.
The most practical theory, which was proposed by historian Thomas Heath, is that Thales would use this principle. From a high point on shore, like a tower, he could form a big triangle between himself, the base of the tower, and the ship. Then, using some simple tools to copy the angles, he could build a smaller, perfectly proportional triangle right there on the land. By measuring the sides of that small, easy-to-handle triangle, he could calculate the sides of the huge, impossible-to-measure one. It's a solution that's not just brilliant, but actually doable.
But really, what Thales did was so much bigger than just a clever math trick. The solution itself is actually less important than what it represents. This was a fundamental revolution in how we think.
This is the real legacy. It's that massive jump from mythos to logos. It's the leap from believing the world is just this chaotic place at the mercy of moody gods to discovering that the universe is ordered, it's understandable, and, this is the most important part, it's predictable. So what's the big takeaway here? This was never really just about triangles, was it? Thales showed us that the physical world obeys logical rules, rules we can figure out and use. He took geometry out of the clouds and turned it into a tool to empower people. This belief in reason, and the power of proof, is the bedrock of all of modern science. It's the radical idea that we can understand our world and, by doing that, start to shape our own destiny.
Which leaves us with one final thought to chew on. In our incredibly complex world today, filled with all these problems that seem impossible to solve, what simple, elegant truth, like a triangle and a semicircle, might we be completely overlooking?